All right, Cal Kids, we're going to go over number 12 from 2-4 homework. I had a couple of you guys message me saying that you needed me to do this one for this video, and so we're going to do the quotient rule with this thing. That's what number 12 is, okay? So I'm going to start out by writing out what the quotient rule is. So f prime g minus g prime f, and we have a helper, so you'll hear her in the background, all over g squared. Okay, so I don't know why. I always start with the g squared because I just leave him as x to the fourth plus x plus 1. I'm going to leave him like that, but then I'm going to fill in my 4 little bubbles, okay? I just always started off with the 4 bubbles, so that way I don't miss a part, okay? So remember that this is your f and this is your g, so f prime is the derivative of x minus 2. Derivative of x is just 1, and the derivative of minus 2 just goes away, okay? Then I just recopy the g down, so x to the fourth plus x plus 1, okay? Now, in this next piece, I'm going to do g prime, which is the derivative of this guy, okay? That 4 is going to come down, so 4x cubed, and then the derivative of x is 1, but then the 1 drops off, okay? Then I have, after that, just x minus 2, okay? All right, now, this first part, I'm going to simplify this top, right? The top is, if I distribute the 1 through, that just stays as x to the fourth plus x plus 1, right? Okay, but now, the deal here is this negative. Normally I tell you to do like plus minus, and that's what we're going to do, but just be careful when you do that because there are 2 pieces here. So when I make that a plus, this has to be a minus, this has to be a minus, right? Okay, now you're not going to distribute the negative through for this piece, this piece, this piece, and this piece, right? That would end up giving us a double negative, which would actually end up being positive. If I'm going to distribute that negative through, I want to only distribute it through this first piece. Or you could distribute it for the second piece and not the first piece. Either way is fine, but I'm just going to do the first piece. And now I'm going to FOIL this guy and this guy together, okay? So that's kind of a weird thing that happens. So I'm taking negative 4x cubed times positive x, and I get negative 4x to the fourth, okay? Negative 4x cubed times negative 2 is plus 8x cubed. I'll zoom out just a little bit. Negative 1 times x is minus 1x, and negative 1 times negative 2 is positive 2. Okay, so that's what I've got on my top, blah, 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 that stuff on the bottom, and now I'm going to simplify, okay? So this x to the fourth plus x plus 1 is there, and then I'm going to combine any like terms that I've got for this top. So x to the fourth minus 4x to the fourth is negative 3x to the fourth. That's gone. Okay, I've got plus 8x cubed. That's that. Plus x minus x, that goes away. And then I end up with plus 1, plus 2, so plus 3. Okay. And I don't think this top part breaks down at all. There's nothing I can use to like cancel down here. So that is just going to be my final answer. That's what I've got. Okay. All right. There is that. Okay, now we're going to go into, you guys should have, Mr. Johnson should give you a copy of the unit circle. Okay, this is the unit circle. Megan and Remington have seen this before. The rest of you will see it in trig, so you're going to be just a little bit lost on this. We're not going to get to too much of this today, but you may need some of these formulas down here at the bottom, particularly this one that says Pythagorean identities, okay? So that is what you're going to be focused on for today. There's a backside of this unit circle that has some shortcuts for derivatives. And we'll go over that when I'm back, but you'll need this sheet. This sheet you're going to keep a hold of. Eventually we'll get a laminated copy of it. Remington and Megan, you probably maybe still have your laminated copy from last year, but there is that, okay? So we're going to do a little bit of 2-5. We're not going to get all the way through this. In fact, we're only going to do like the first 3 examples. Actually, like 2.5. We're only going to get about halfway through example 3, okay? But there is that. So you need this unit circle. For today, you need 2-5 notes, and then you also need that half sheet of paper that Mr. Johnson should have given you, and it's laminated. It is, I think, blue, and it has these guys on the front side of it, okay, and then on the back side it has some other weird ones that's like inverse sine, right, okay. So the front side is what you need today, where it says the derivative of sine, the derivative of cosine, okay, so in trig, we probably talked about this in geometry, but there's like 3 main trig functions, which are sine, cosine, and tangent, right? Okay, and then the reciprocal identities, what's what they're called. The reciprocal of sine, well, let's start with reciprocal of tangent. The reciprocal of tangent is cotangent, right? The reciprocal of sine and cosine, it's like their partner, basically. This one goes with secant, is what it's called. And then this one goes with cosecant. Okay, you make that make sense for me, right? Tangent and cotangent, like, I get that one. But, like, wouldn't it make more sense for cosine and cosecant to go together and sine and secant to go together? Like, that would make sense, but it doesn't. I don't know why I didn't make the rules. Like, I would have designed it to be not stupid, maybe, if I was in charge, but I'm not in charge. So, sine and cosecant go together, and cosine and secant go together. So, these are the 6 main... Whoa! Oh, building a fence? These are the 6 main trig functions, and so they are these guys right here, okay? And that's on your blue laminated sheet. Laminated because you're going to want to keep a hold of him, okay? So there's homework problems up here. You might be able to get through, like, the first half of them. I don't know. Maybe the first 5 of them. I don't know. But let's talk about these derivatives right here. These, because this is a laminated sheet, I let you use this on your test. I do not expect you to memorize these. However, as we get doing these, you may remember or memorize some of them, particularly these first 2. So the derivative of sine is cosine. The derivative of cosine is negative sine, okay? And maybe when I get back, we'll look at, like, the sine functions, right? Okay, so, like, sine, if I were to graph him, sine looks like this. I think we maybe talked about him in this class. You guys will get familiar with this in trig. Megan and Remington, you probably already know, like, or maybe remember this from last year, but that's the graph of sine. If I take the derivative and look at, like, his slopes, right, and I graph his slopes on a coordinate plane, his derivative is going to be cosine. So his derivative mapped out looks like this. Okay, that's what he is, right? So this just has to, like, there's the pattern between the two. The derivative of sine of cos is cosine. The derivative of cosine is negative sine. And we can see more of that and talk about more of that as we get going. But one thing, if you're wondering, I told you that there were 4 main ways to finding the derivative, one of which was the power rule, which we use a ton, okay? That was the n x to the n minus 1, that rule, right? Then yesterday we did the product rule and the quotient rule, right? Okay. Then there's one more that's called the chain rule, okay? So product, quotient, chain. Chain rule we have not done yet. I forgot to tell you that these 2 is what we do in section 2.4, and then we take a little bit of a break and we do derivatives of trig functions first with the product and quotient rule before we do chain rule in 2.6, okay? I forgot to tell you, it slipped my mind that 2.6 doesn't, or chain rule doesn't come directly after product and quotient. We take a kind of a little hiatus and do trig functions, derivatives of trig functions, before we get to the chain rule. So if you're wondering, yes, we will eventually do that 4th way, which is the chain rule, but not until after we do trig functions. Are you going to learn some derivatives? Okay. All right. We've got a helper. Okay. All right, so first things first, we have, where'd my example 1 go? Example 1, we've got this thing going on and they want us to find the derivative of this right here. Okay, now, make sure that you understand that this x is trapped inside of the sine function, right? It's like sine of x, okay? So this is one unit together right here. And then we've got kind of this x just off by himself over here, but what operation is happening in between those two, right? It is a multiplication, right? So this is technically a product where this guy is the f part and this guy is the g part. So we're going to do the product rule, but within that product rule, we're going to use some of these derivatives up here, okay? So exercising the product rule is f prime g plus g prime f, okay? Do you have him memorized yet? If not, you should, right? The faster you do that, the better things will be for you. We want to just fill these little bits in and then we'll be good to go, okay? So they want to know the derivative of f, that's what f prime is, okay? So x, the derivative of x is just 1, right? If you don't remember that, this is x to the first power, so the 1 is going to come down in front, and 1 times x to the, if I subtract 1, that's 0 power. But x to the 0 power, goodness, x to the 0 power goes away, so it just ends up being 1, right? Okay, then g is sine of x, so I've got that going on, right? 1 times sine of x.
So we're excited to have them with us.
All right. Then we have g prime. I want to know the derivative of g, the derivative of sine, and we have that up here. The derivative of sine is cosine. So I'm going to put cosine in this little blank. Cosine of x, and then times f, which is x, all right? And then all I'm going to do is simplify. So 1 times sine of x is just going to give me sine of x, plus these two multiplied together. It's worth noting that when I multiply these two together, I cannot just multiply those x's and make that cosine of x squared. That's not how that works. This one is trapped inside of the cosine and this one is not. So the proper way to write that, I usually take this guy and I put him in front. So x cosine of x, kind of like what we began with, x sine of x, right? And then I cannot put these two together. So this is going to be my final answer for the derivative, okay? My function was called y, so you could call this y prime. You could call this f prime of x if you wanted to. They also call it dy dx, dy over dx. Okay, we'll use this notation a lot going forward, like maybe in chapter 3, maybe right at the end of chapter 2. I'm not sure. I don't remember where something called implicit differentiation lies. We might do that like the last section of chapter 2. I don't remember. Or it's the beginning of chapter 3. But anyway, all of those notations mean the derivative, right? Okay, so that was an illustration of the product rule. Now they're going to have us do the quotient rule because this is a quotient, right? Okay, find dy dx, that's saying find the derivative. Okay, so this is the f and this is the g, and so I want to do the quotient rule. Okay, f prime g minus g prime f all over g squared, right? You have this guy memorized yet? I start with all my little bubbles. That way I know I don't forget anything, right? If you start with your bubbles, you won't leave anything blank and forget anything, right? And I start with, I don't know why, I always put the bottom in first because I'm like, yay, it's like a bonus. I don't have to do anything with that, right? Okay, yet, okay? All right, they want us to do f prime here, so it's the derivative of that top, the derivative of sine, which we already did over here. The derivative of sine is cosine, okay? So I'm going to put cosine of x here, and again, you can put parentheses around that guy. A lot of times they don't. They just say cosine of x, but just know that that doesn't mean cosine times x. That means the x is inside of the cosine, all right? So just so we're clear, that's how that works, all right? Then they want just g, which is sine of x, okay? I want g prime, which is the derivative of this guy. Okay, now, how do we do the derivative of that guy? It's okay. I got it. It's right here. It's okay. You leave it. Okay? Yes, yes. Thank you for being my cookie. Thank you. Okay? Okay. You're going to hold it. Okay, put it over here then. Put it over there. Okay? All right, so g prime is the derivative. I'm going to do the derivative of 1, which goes away, and the derivative of cosine is negative sine of x. That's like this guy right here, negative sine of x, okay? Then I want just f, which is sine of x, okay? And now I'm going to simplify that top part, okay? So I've got cosine times sine. I'm just going to say cosine x sine of x. It's just those multiplied together, okay? Now I've got a double negative, so I'm going to do plus minus, which is going to turn that to a plus. Two negatives right here is going to make a positive, right? But then I've got right here is sine, so that's plus. Sine times sine is sine squared x, right? Okay, so just so you know, sine of x, that whole thing squared, because there's two of them, is the same thing as writing sine squared of x, but it is not the same thing as sine of x squared. I think we've talked about that before. You want to do sine of x first and then square that value. You don't want to square the x first and then take sine of that, okay? So those are not the same thing. All over 1 plus cosine of x squared, like that. Okay, hold on just a minute.
Okay, so I'm going to introduce you to a word. Actually, before I do that, I'm going to tell you a little story. When I was school-based and supporting students with intellectual disabilities.
Okay, all right, so now, if you guys circle this or box it or whatever and say answer done, I will say totally fine, that's okay. But one thing that you can do is that, yes, thank you. One thing that you can do is my two pieces that I have right here, they have a sine of x in common, right? So what I'm going to do is I'm going to yank that sine of x out, and that's going to leave cosine x. Thank you. Plus, does that work? Yes, thank you. Oh, what did I do here?
the term that I use to help me kind of understand
Hey.
the word dimension. And what
Cosine
that
x
means
plus
is,
sine of x.
dimensions,
That's,
when
I
I
thought
think
it was
of
going to be
dimensions,
1.
like, are physical, right? So if
I did something wrong.
go get a sheet made,
I did this earlier and it came out like
I need to
weird.
give the
Okay,
tailor
honey. All right. I love you. Yes, thank you.
I'm gonna tell the tailor what my dimensions are.
G. Oh.
It's not useful. He can't design for me.
F prime. That's where I went wrong. That's where I went wrong. You guys are yelling at me. My G is not sine of x. My G is 1 plus cosine of x. That's the problem. That's the problem. Okay. Sorry. Oops. Oopsie daisy. Let's get rid of this. Eee, you guys are yelling at me, I'm sure. Like you did it wrong all the way back at the beginning. Okay, so let's fix that. So cosine. So this one I'm gonna have to distribute through. Cosine times 1 is cosine x plus cosine times 1 is gonna be cosine squared x. Okay. All right. Yes. Here we go. Then sine of x times sine of x is plus sine squared x. Okay. All right. So again, this piece is what I screwed up on. See? It's very easy to make a mistake. I'm going to distribute that cosine through, so I've got that, and then I end up with those 3 pieces. And then the 1 plus cosine x squared on the bottom. All right, now, this is, if you say answer done, I'm fine. That's totally good. But you trig kids will eventually get to the point, and Megan and Remington maybe see this guy right here, cosine squared plus sine squared. And that is a special thing. Anytime you see sine squared and cosine squared or any squareds, when it comes to trig functions, I want you to go to your unit circle and I want you to look at these, they're called Pythagorean identities, okay? Pythagorean identities. So, and we'll talk about where these are generated from, okay? So, in a nutshell, what? In a nutshell, sine represents the x-coordinate, right? X-coordinate. Cosine represents the, no, excuse me. Sine represents the y-coordinate, cosine represents the x-coordinate. So basically I have y squared plus x squared equals 1. And this is actually the equation of a circle, right? Y squared x squared equals 1. We've been doing that in trig, right? So in a nutshell, that's where that comes from. Or it's like a squared plus b squared equals c squared for Pythagorean theorem, right? Okay, so that's technically how these are generated from. But what we have going on here is ways to simplify things. So we have that sine squared plus cosine squared equals 1. Okay, so sine squared plus cosine squared equals 1. If that is true, then down here when I go to simplify, sine squared plus cosine squared, or vice versa, this is equal to 1, which is kind of funny. Now I have cosine x plus 1 over 1 plus cosine x squared, right? Well, these two things are the same thing, right? This top part, if I rewrite him 1 plus cosine x, this is the same thing as one of these. So what I can do is I can cancel them to make only 1 left on the bottom. What's left on top? Nothing. So I put a 1 there, and then I still have one of these 1 plus cosine x's remaining, right? So I cancel this with one of these guys, and this is my final answer, okay? So again, if you are like, yep, got the derivative, and you leave it like that, yes, that's totally fine, only because trig, like my trig kids that are doing trig right now, this is not going to look familiar to you to simplify that, and that's okay. But just so you know, it does come out to be a little bit nicer when you use those Pythagorean identities to simplify, okay? All right, there you go. Let's do part 3. They want us to find the second derivative, and then they want us to actually plug a value in. We're going to wait to plug that value in until I come back, because I'm going to show you, like, I want to be there when I show you how this unit circle operates. But they want us to find the second derivative of secant of x, okay? So if I'm looking, I want to find the first derivative, which I'm just going to call f prime, okay? And the derivative of secant right here is secant tangent, okay? Remember that, like, this x is trapped inside of the secant. This x is trapped inside of the tangent. So what operation is happening between secant and tangent? It's like secant times tangent, right? Secant of x times tangent of x. That's what the derivative of secant is, okay? And that's the first derivative. That's easy, right? That's only one piece. But they want us to find the second derivative. So basically I have to find the derivative of this thing, and now I have to use the product rule because this is a product, right? Where this is the f part and this is the g part, okay? So product rule f prime g plus g prime f. I got my pieces here. Oop. and I've got to I've got to find these values. So the derivative of f would be the derivative of secant, and that's that secant tangent again, secant x tangent of x. I should have wrote that bigger. I'm sorry. Secant x tangent x, that's what f prime is. G is just that tangent x again. Boop. Come on. This is just tangent. And then g prime is the derivative of g, and the derivative of tangent is right here, which is secant squared. Secant squared x, okay? And then they want just f again, which is secant of x, okay? So there is that, all right? Now I'm going to go down here, and I'm going to simplify just these pieces right here. Secant x, tangent x, and another tangent x. That would be secant x, tangent squared x. It's like there's two of them, right? Okay, if you think of this as like secant is x and tangent is y, this is xy times another y. That would be like xy squared, right? Xy squared, okay? It kind of operates the same, okay? Plus, I have secant squared times another secant, and that will end up being secant cubed x, right? Okay? Now, one thing that I see is that these two terms that I have right here, I can pull a secant x out. And if I do that, I'm dividing by that. This will be tangent squared x plus secant squared x, okay? All right, now I see those trig functions again, tangent squared plus secant squared, and I'm gonna like go back to the Pythagorean identities and see if I've got something where we've got going on here. All right, this guy says that 1 plus tangent squared is equal to secant squared, okay? So we can do some manipulation there, but one thing is I want tangent squared plus secant squared, okay? Now, we can do some manipulation with this, like, for instance, if I subtract tangent squared theta here, okay, I get that 1 is equal to secant squared theta minus tangent squared theta. So if it was secant minus tangent instead of secant plus tangent, I could replace that and cross that out and put a 1 there. But it is minus and not plus, okay? So I'm looking at this down here and I'm like, I don't think I can do anything with that yet. I don't think I can, okay? So what we're going to do is we're just going to leave it like this for now. We're going to leave it like that for now. We do have to end up plugging in pi over 4, and we'll get to that, right? But for now, this is the product rule for the second derivative of a function. And some of you guys are like, okay, why would I ever use a second derivative? Going forward, and I think in example 4 and example 5, we'll start talking about more uses of a derivative. So like the first derivative is equal to the slope of a tangent line. It's like the instantaneous rate of change, right? But it's also used to determine velocity. And I think maybe we've talked about that before. The second derivative, though, is the derivative of velocity, which actually ends up being acceleration, okay? So second derivative is very useful when I'm dealing with a particle or something that's moving. I can take the second derivative of its path, basically the equation of its path, and find out the acceleration at any point in time, okay? And that's kind of exciting. So that is a use of the second derivative going forward. All right, so I'm going to stop there. Go ahead and do as many of these as you can. I don't know I don't have the book in front of me, so I don't know what is what, but try to help each other. I know that this is kind of a little bit of a foreign territory for some of you guys just because you haven't had some of these trig functions yet, and that's okay. It'll be fine. It's not too terribly difficult, but there you go, okay? Help each other. Megan and Remington, help the juniors. Goodbye.